Hello, everyone. It's great to have you here with us today. My name is Megan Donaldson. I'm the Alumni Relations Manager here at Trinity Development and Alumni. I'm delighted to have you here for this latest episode of our Inspiring Ideas at Trinity webinar series. Today, we'll be hearing from renowned immunologists Cliona O'Farrelly and Luke O'Neill as they take us through the connections between metabolism and immune system and share insights from some of the groundbreaking research that's happening at Trinity right now. Before I hand over to them, I just want to cover a few practicalities. This webinar will last just under an hour. We will take audience questions after the discussion at the end, but you're welcome to submit your questions throughout the webinar. You can do so by clicking the Q&A button that'll appear either at the top or the bottom of your screen, depending on how you're joining us. I mean, you can just pop them in there and we'll try to get to as many as we can towards the latter half of the webinar. This webinar is being recorded and will be available for later viewing on our Trinity Alumni YouTube channel. So if you enjoy it and you want to share it with your friends later, you can definitely do that. Now I'd like to introduce you to our speakers. Professor Luke O'Neill is Chair of Biochemistry here at Trinity, where he investigates inflammation and the innate immune system, and has made pioneering discoveries in the area of metabolic reprogramming and immunity and immunometabolism. He is also a member of the Royal Irish Academy and a Fellow of the Royal Society. Luke has a weekly science slot with Pat Kenny on News Talk, is a frequent contributor to publications including the Irish Times and Irish Independent, and is the author of several books, including Immunology, a scientist's guide to our amazing existence, as well as a science book for children, the Great Irish Science Book. His latest book, To Boldly Go Where No Book Has Gone Before, was published earlier this month. We're also delighted to welcome Professor Cliona O'Farrelly, who's been Professor of Comparative Immunology here at Trinity since 2007. With a background in comparative liver and cancer immunology, her research focuses on the innate immune response to viruses and how it mediates resistance to viral infection. She was the first woman to be awarded a PhD in immunology in Ireland, the first female president of the Irish Society of Immunology, and the first female chair of Fellows of Trinity. She has served as co-chair of the Department of Health's COVID-19 research subgroup, as well as serving on the board of Amnesty International for over 9 years. And she has authored or co-authored over 200 papers and reviews in immunology. So welcome to you both. Thank you very much for joining us. And I will now hand over to you, Cliona.
Thanks, Megan. And start the video. Yeah, is it not, why is it not starting? Can't see me? Start my video.
There we go.
Thanks very much. Do Luke and I start first, or will we go straight into the kind of the intro? No, you want me to
go right ahead, Cliona.
Okay. For some reason or other, my my computer is quite so I should have said hello to everybody first, and welcome to everybody. It's this is a really exciting opportunity here to talk to you all, and to have a conversation with Luke. He's only down the corridor, but because he is just so in demand everywhere, it's pure chance if you get to chat to him. And no matter when you meet him, he is always got interesting stories to tell, and already you are going to hear about some of those. He was telling me just now before coming on about this exciting new paper that his group has published, which is directly relevant to what we're going to discuss today. So first of all, you have all gathered from COVID that our immune systems are unbelievably complex. We have immune cells and immune molecules absolutely everywhere in the body, which is something that really, I think, we're trying to forget the way we illustrate the immune system. So they're in the blood, in the gut, in the lungs, in the liver, in the skin, in our genital urinary tracts, and in our brain. And another really important thing that lots of us forget is that actually every single cell type in the body is capable of providing defense, of detecting infection, viral infection, and responding. And of course, these are really important ones would be epithelial cells that line our nasal tracts, our guts, and our lungs. And they detect infection and can produce antimicrobial peptides and really important antiviral mechanisms. And so therefore it shouldn't come as a surprise that, but we're only really discovering it now in this century, that as well as fighting against infection, the immune system has a really important role in preventing or mediating autoimmune disease, in preventing or mediating cancer, and the inflammation that is part of the immune response actually underpins most disease. Lydia Lynch, one of our stars here in Trinity, gave a fantastic lecture at Schrödinger 75, which Luke and colleagues established to celebrate Schrödinger's lectures in Trinity, where she was one of the first to really kind of describe how the immune response or the immune system is critical to so much disease. And so for this reason, immunotherapies, therapies that direct the immune system, will possibly be of use in most diseases. And then even more controversially, it should be possible for us to devise vaccines that could actually prevent most diseases. So Luke told me about this review that came out just recently, basically reiterating just what Lydia had said 5 years ago. And this is available for you all to read. We can give you the link to it. Full of complicated science, but the basic message you will definitely get. And so we know, and this is an illustration from it, illustrating how, I don't know, I hope you can see my pointer here, how systemic chronic inflammation, right at the center of this diagram, is contributing to cardiovascular disease, cancer. A lot of mental health is probably mediated by inflammatory mechanisms, autoimmune diseases, neurodegenerative immunosenescence. That's aging, the problems that happen to our immune system. And these are many of the things that contribute to that systemic chronic inflammation. Chronic infection, but also physical inactivity, obesity, dysbiosis in our guts, what we eat, when we eat, and then social anxiety. They themselves contribute to the inflammatory mechanisms that are not working entirely the way they should in these diseases. So we've described the huge potential of the immune system, but then the huge potential of the immune system to mediate disease. So what can we do right now to help our immune systems? Now, it's further complicated by the fact that everyone's immune system is different. And again, all of you will have seen this during COVID and will be aware of it anyway during your lives, that everybody's response to an infection is actually different. And we know during COVID-19 that some people didn't get sick at all. That's my area of research at the moment. Some people get sick and get better. Unfortunately, some people get sick and die. And also, unfortunately, some people get sick and develop chronic symptoms. So long COVID is a very real thing. Now, why is it we respond differently to infection? Now, of course, if in a class I would ask, and immediately the students would say, our genes are clearly very important. However, at the moment, we can't do anything about our genes. And it's useful to know that in actual fact, genes probably only contribute about 30% of the variability in our immune responses. Two other major things that, again, we can't do anything about is our age and our sex. Again, you will be familiar with the fact that men were more inclined to get sicker and to die in SARS-CoV-2. But in general, we know that women are more susceptible to autoimmune disease. So sex is really very interesting. But what drives all of these effects is immunometabolism. Now, what is immunometabolism? This is Luke's topic. This is why he's professor of biochemistry. So it's amazing that he's silent here, and it's a bit unfair because he should be coming in immediately to modify my description of what it is. And this will be the topic of our discussion. Basically, it's about the energy that a cell generates and uses, and the metabolites that it uses and generates in order to do that, in order to carry out its function. And of course, we can immediately imagine that the cell energy and its fuel is going to be really affected during immune activity when we produce many, many more immune cells and lots of molecules. But equally, we know that the production of cell energy and its use and the production of these metabolites and their use will themselves affect immune activity. And some will be immunostimulatory, make the immune response work better, and some are immunosuppressive and suppress the immune response, which we want sometimes, of course. And that is exactly the paper that Luke has had. Luke, one of the brilliant PhD students in Luke's lab, has had accepted today, and hopefully he will tell us more about it. So what affects the immunometabolism of our immune cells and the defense mechanism of our other cells? And of course, it's diet. It will have a huge thing. What we eat, what we drink, when we eat and when we drink. Again, we can discuss this with Luke a little bit more about the timing. There's huge interest in fasting and both and the timing of when we eat, and the critical one, how much we eat and drink, will have huge effect. And it's probably one of the main reasons of this dysregulated inflammation that we see in the 21st century. It's the first time humans have lived in a time of dietary excess, and we didn't evolve to do that. So it's presenting its own challenge. Body weight definitely affects the immunometabolism of our cells, and that was one of the first studies that Lydia produced when she started down the road of immunometabolism. It was out in Vincent's with Donal O'Shea, an endocrinologist you all know well, where she found that natural killer cells from obese people with a high BMI, did not function as well as NK cells from people of lower BMI. We know stress has a real effect on both the immunometabolism of our bodies and therefore on the immune system. And of course, sleep. There's data emerging from quite a number of sources showing that sleep is more than just lack of consciousness, that a whole lot goes on in our bodies and in our brains, often involving our inflammatory cells and the inflammatory mediators. And if we don't get enough sleep, it contributes to all of the other things that we have talked about. Now, what is the biggest impactor, or to use a statistical term, mediator of all of these is how much we move. So exercise. It, of course, the amount of exercise we take will hugely influence the diet. It's emerging, it hugely influences our microbiomes. And of course, it plays a role in our body weight, in our stress, in our sleep. And do I have it here? I'll talk about that in a minute. Another paper came out, I just mentioned this with Luke. It affects also sexual activity. There's a paper that has come out that has said that exercise can have as beneficial effect on erectile dysfunction as Viagra, probably due to how it modifies the inflammatory mechanisms mediating cardiovascular disease. So, of course, one of the things that's really going to interest this audience is the type of immune response, as well as we've talked about role of infection, but something like a quarter of us are going to get some form of malignancy in our lifetime. And what can we do to actually decrease the chances of that? And again, the data is emerging that physical exercise has a very active role on our immune systems that are important in protecting us against cancer. And so this is we can give you a link to this paper as well, so that you have it for yourselves. And it just describes the effects that regular exercise can have on specific or at least immune activity. So decreases chronic inflammation, which we know contributes to cancer. As I said, changes the microbiome, can help heat up a tumor. I know this sounds really ridiculous, but we as immunologists talk about tumors being cold, not being able to be detected by an immune response, or hot, expressing molecules that can be detected by the immune system. And exercise seems to make a tumor more detectable. Probably is actually that the exercise is making our immune system more active. And we can talk about specifically what it does to the NK cells. Like, as I said, the natural killer cells are a really important anti-tumor population in the body. So we can discuss all of these in the conversation. So is that the last? Yes, that was the last slide. So that's a whistle-stop tour to kind of introduce the topic. And now maybe we can go into some discussion of some of that. So can I stop sharing now? Has it stopped? Stop share.
I'm in, Clint. I'm allowed in now. They blocked me in case I interrupted you.
You would have, and you should have. I was really missing you.
That was a great account of it. Well done. And hello to all the alumni tuning in. Very nice to be with you all, even though we can't see you. Yes. I'm in my office. It's like COVID times, right? We're stuck in our offices on screens again. We're well used to it, I guess.
But we would love to see some of the people, because I bet there's huge range, and that they're all parts of the country and of the world. So it's really, and actually we didn't comment, Luke, that both of us are alumni.
We are alumni. We are indeed. I graduated in 1985. I won't ask you when you graduated.
I'll tell. I'm very happy to boast about it.
What year was it?
I started, because this is right, I started 50 years ago, almost to the day.
Good Lord, isn't that marvelous?
Yes. And the other claim to fame, which I love telling people, which embarrasses my husband, met my husband. Yeah, we did chemistry practicals, and the very first one would have been almost today. It would be on Friday.
Wow, there you have it.
The first time we started chemistry, Ken Mealy, and I ended up marrying him for those.
Isn't that marvelous? Just shows you, you know. Yeah. And just to reiterate to the alumni, Cliona got the very first PhD in immunology in Ireland. That's a really good boast. I think it's tremendous, you know.
That's ancient history. Yeah.
What was your PhD about, Cliona?
Neutrophils. I was only talking about
neutrophils.
Today. Yeah. No, that was my undergraduate. I gave blood today, and I was talking about the neutrophils. My undergraduate project was in neutrophils, and that's what gave me my love of immunology.
Right.
Those cells are absolutely amazing. I used to take a blood sample in the morning at 10 o'clock. I would take out my neutrophils, do an experiment, and I'd have a graph by 3.
Wow.
And I'd be gone. Yeah.
That's very satisfying, isn't it? You know. But so my other question is, it's amazing how much discoveries happen since then, not because you're of a certain age, but in our field of immunology, it's been staggering, hasn't it? I mean, like what I tell our students is, if you printed out the papers, say in the late 70s, they'd be this high, wouldn't they? Now it's like up to the rooftops kind of thing. You know, the knowledge we've acquired about the immune system in that period.
And that's why it's so hard to teach, Luke, is because
it's a real challenge. Yeah.
I
began my PhD in 85.
Yeah.
And that really was the Stone Age as well now, in a way. Now, we knew some of the key moving parts. And we knew about what's called the MHC, for instance. We knew about antibodies, and they're two very important things. No knowledge of the innate system, really. No knowledge of cytokines. It's a bit like a car engine. We knew maybe 5% of it then. And now we know 80%, something like that anyway. And so the amount of knowledge we've acquired is spectacular, isn't it, in the past say 20 years in particular.
Yeah.
It's amazing how much knowledge we've learned in recent times.
But what then is also a little bit disconcerting is that as our knowledge has increased exponentially, our understanding of exactly how it works in a walking, talking human being is still really limited.
It is limited, yeah. But the ultimate proof for all of us is if you intervene clinically.
Yes.
You target one part of the immune system.
Yes.
And then you see a big effect on rheumatoid arthritis, for example. The big triumph I worked on rheumatoid as a PhD student. And at that time, they gave patients like Gold's compounds or chloroquine. You know what I mean? And then the cytokines came along, and the cytokines are key regulators of the immune system. And one of them is called TNF. And you block TNF and you get relief in rheumatoid arthritis. And that's one little example of how the discoveries can be useful in people. So even though we don't know all the answers, there are therapies there that do work a bit for some of these diseases. And that's I
think maybe that's what's happened exponentially as well, is we've discovered so many of targets that do have an effect. Okay, they don't lead to perfect understanding of the mechanisms, because we can't prevent the disease or completely cure it in everyone. But because they're showing, exactly as you say, effectivity. And that's why this work that you're doing about the metabolites is really so mind stretching in a way.
Yeah, it is. It's weird. Yeah. And just to tell people about that. So I did my first degree in biochemistry. Were you biochemistry as well, Fiona? You're microbiology, right?
Yeah, I'm microbiology.
Okay, so you were closer to immunology than me. In biochemistry, we had about 10 lectures out of 200 about immunology in our degree, back then.
Who taught that?
Alex Whelan. Remember Alex?
Oh, it was Alex. I didn't realize that.
He had a huge influence on me. When I was in my final year in biochemistry, he gave 5 lectures on these newfangled things called cytokines, never forget. Right. And then I got into cytokines as a result, so just show you the importance of a lecturer to students. And then that was the beginning, in a sense, of my journey. And I knew then myself, get to mechanism, understand the underlying component parts and how they work. And then we got drawn into metabolism, because about 10 years ago, immunologists began to spot these strange metabolic changes in the immune system. Wasn't known before, really. And suddenly a whole new vista opens up, integrating biochemistry back into immunology, and then finding out what these metabolites do. And my lab had shown changes, very specific changes in certain so-called metabolites in our bodies during an infection, for example, and then we need to track that down in more and more detail. And our recent discovery, I might as well bang on about it. There's a very important thing in your body called Krebs cycle. Now, any alumni listening who've done biochemistry would know what Krebs cycle is, I hope, or the leaving cert. It's also called the TCA cycle. Discovered by biochemists 60, 70 years ago, and it's very important for energy. And Krebs cycle burns carbohydrates, and then eventually you make a thing called ATP, and ATP is the energy currency, it's the battery for all of life, right? And then we find in my lab that cycle goes weird in the inflammatory state. So in inflammatory cells like macrophages is our favorite cell type. Now the macrophage is your frontline cell in the immune system. We notice that Krebs cycle goes weird. Byproducts come off that are quite toxic and begin to irritate the body in various ways and drive inflammation. But very importantly, and Cliona kind of mentioned this in passing, there's lots of off switches in the immune system as well. That's why it's so complex. There's loads of ways of turning it on, and then you got to turn it off, especially at the end of an infection. You want to ramp it down, you see. And we found a metabolite coming off Krebs that was anti-inflammatory. In other words, one bit was pro-inflammatory, another bit was anti. And that's the one that we've tested now as a potential new anti-inflammatory medication. And our paper that just got accepted is all about asthma. And I guess as many alumni would know what asthma is, the incidence of asthma has gone up a lot in the past 50 years. It's reasonably well managed with certain things like steroids will suppress some of the inflammation. But we found now our itaconate really works in asthma, especially now in the preclinical world, not in patients yet. And a subtype of asthma called eosinophilic asthma, which is one nasty type of asthma, we now have potential that our itaconate molecule, it's called itaconate, by the way, that is a natural anti-inflammatory, and we could use that now as a possible therapeutic, and then we're very excited. And in fact, the other excitement is I told Fiona the other day, I've got a company now developing that in humans, and we're going to do our first trial in December in humans with an itaconate-based molecule that will hopefully be anti-inflammatory in different contexts. Cool. And that came out of a very weird development of integrating metabolism into the immune system, which, as Cliona would agree, was nowhere 10, 15 years ago, really, was it? If you went to an immunology conference, there might be one session on obesity, maybe, but there was hardly anything in there.
Oh, there was nothing. There was really, they were considered to be hardly connected, which is hard. Can I tell them about this book, Luke, when you talk about the Krebs and the Warburg, there was that particular pathway, Warburg showed that pathway was disrupted in cancer, and he was an amazing biochemist. And even though this is quite sciencey, I still really recommend it to give some insight into how those pathways that Luke is talking about were discovered. And he was an amazing scientist, a Jewish scientist who lived in Berlin all during the Second World War, and he was gay, wasn't he? That's right.
He was, yes. And Hitler kept him alive.
Yes.
Hitler was terrified of cancer.
Yes.
And he was a key cancer researcher. You know?
Yeah.
And of course, as Cliona knows, the tumors have a very strange metabolism. They've got a massive appetite for glucose. They burn nutrients in funny ways. And Warburg discovered that. So Warburg saw cancer as a metabolic peculiarity in a tumor cell.
Yes.
And then my lab and several labs about 10 years ago, the same strange Warburg metabolism is in immune cells as well.
exactly.
And that link to cancer then becomes really interesting. When you connect the two, then you can come up with all kinds of ideas.
Yes, and so then that's what's emerging now. That it's the conversation between the two of them, the changes in the metabolism. So the altered metabolism from the cancer cell can really influence the immune system, and equally the immune system, when it's switched on, can change the metabolism of the cancer. So it's a huge area for research. Luke, we forgot about the questions.
Oh yeah, well, there are other questions, Neil. I didn't realize.
Yeah. So will we keep talking about this? Have we seen any?
We can talk forever, but give us a killer question.
Increase in idiopathic anaphylaxis and our autoimmune disease since COVID-19. So
that's an interesting one.
Yes, it is, and there is evidence. Yes.
Well, the fact is, any virus will disturb the immune system. That's the bottom line. These are vicious creatures, remember.
Exactly.
They go into our brains, they're in our liver, they're in our hearts, and they will turn on the immune response, of course, because the immune response has evolved to fight viruses. But the trouble is, in some people, the immune system goes out off kilter. And then you get long COVID and you get various things like that developing because your immune system has been disturbed by this virus.
Exactly.
And then sadly, you do see these consequences. But as Tina said, it's a minority. Most people, evolution makes sure we're all fine.
And to get rid
Given that we've all got different genes, evolution made sure of diversity among us, remember.
Yes.
Just in case a virus came along, some will survive, some sadly die, and then some get long-term consequences, including autoimmune diseases as a result. I mean, the big one I talk about, and you do, is Lyme disease. That's always been around for a long time. Lyme disease is caused by these ticks, which inject a bacteria into your body. The bacteria is called Borrelia. And you get a massive inflammatory response to Borrelia. They get very bad arthritis. Many people develop persistent symptoms post-Lyme and end up with fatigue, and just like long COVID in a way. And that must be an autoimmune response being triggered post-infection because the immune system is now out of control and begins to attack your own tissues. And one of our dreams, as Tina would agree, is to find the basis for autoimmune. We still don't know what causes MS or rheumatoid, really. It's a big mystery, you know? And it could well be driven by infections yet to be characterized or discovered. The big breakthrough there was MS. I'm going to clean it out. About a year ago, there's really good evidence of Epstein-Barr virus, a virus triggering MS. If that pans out, you can now vaccinate against EBV and stop them.
Exactly.
So the hope is there could well be an infectious origin for any autoimmune disease would be the dream we have. Because now you can get a vaccine and stop. Can you imagine a vaccine to stop rheumatoid or MS or motor neuron disease, Parkinson's? They're all, as Clina said, they're all in the same group of immune-mediated diseases. So therefore, and vaccines, the great triumph of vaccines is it gets the immune system to work properly. That's the goal of a vaccine, remember? So why not have a vaccine to stop autoimmunity? That'd be a real triumph that we're all heading towards. And my lab is involved in this, and so is Clina. So that's the real goal in some way.
Yeah. Can we tell them a little bit about those? Because there are two papers in particular that really kind of develop, and this is what some of the questions are talking about, that concept of infection leading to complication. So it was an enormous study. It's not just one tiny little thing. It was the one that of the EBV in multiple sclerosis is 15,000 people were looked at. And then there's another totally different study in a different country, and it's to do with, I think I sent this one to you, Luke, where they looked at 2,000 matched pairs of people with 200,000 of matched pairs in the what are they called, veterans.
Yeah, that's right.
And they divided them into two groups, those who had received the flu vaccine and those that hadn't.
Right.
And those that didn't receive the flu vaccine were more likely to develop Alzheimer's.
Didn't know that. That's interesting. Yeah.
So this is suggesting that viral infection can lead to neurological defects in some people. So this is what comes back to the kind of the central question here is, what can we do about our immune systems and driving the metabolism so that it's protective, but it won't protect all of us all of the time.
Yeah. Well, the great phrase, Clina, it's nature via nurture. In other words, you've got a built-in immune system that's different. Me and you, we have different immune systems. Exactly. Like we have different faces, you know. Yeah. And then the trouble is that will get revealed through exposure to a virus or a bacteria or obesity or lack of exercise gets read out. In other words, I might have, through dumb luck, the wrong set of genes. And when I get a virus, I develop MS and you don't. You know, we
Yes,
both get the
exactly.
virus, we both get Epstein-Barr virus. But
Exactly.
your genes are able to handle it better than me, and my immune system goes rogue and begins to attack my brain. So it's always, that's why it makes it complicated. People often ask me about those complexities. It's never nature or nurture.
It's
So always nature via nurture. In other words, you reveal your nature through something happening, you know.
Yeah.
And a good example I've given in one of my books is, imagine drumming is genetic. In other words, the best drummers have the right genes.
Okay.
You never reveal that unless you teach someone to play the drums, you know.
Yes.
So that's how you reveal the gene, through teaching someone. Oh, that guy's a great drummer. Now, there isn't a gene for drumming as far as we know, but it's that kind of thing, you know. There
is, Luke. There is. I'm really going off topic here, but somebody was watching me at a traditional session and then said to me afterwards, Kiana, how do you do that? I said, what? And he said, clap so completely out of beat. Okay.
So now, the trouble is, as you know, it gets very complicated. You weren't exposed to drumming as a child, maybe. That could have been the reason. You know?
Okay.
Never know. But I think it's a very important concept. It's a very important notion. And your work, Cliona, on COVID and the interferon business, right? And the antibodies. You tell our alumni about that, because it was a very important study.
Yeah. So it's back again to appreciating that, or learning that some people are much more vulnerable than others. And it is men. There is a whole thing we can talk about the sex thing as well, how, why men are more vulnerable to the severity of infection. But as part of a very big collaboration across the world, actually, there's 100 people right across the globe have been studying this, led by a very famous immunologist or a doctor who's interested in immunology, Jean-Laurent Casanova. The audience will really like his name. And he was very famous for discovering abnormalities in the genes that code for some of the proteins that Luke was talking about, and the cytokines that are really important in very severe infection. He was seeing small children with, this is before COVID. During COVID, he asked if there might be something similar happening, making some people more vulnerable to the very, very serious effects of COVID. And with two enormous papers that came out in 2020, very early on, he and the whole international group showed that they gave two reasons for why, but it's in the same pathway. There are these cool cytokines called interferons, which block cells from getting infected with virus, terribly important to our early stage of response to infection. And it turns out that some people have got mutations in the genes that code for some of the interferon pathway. So that explains 15% of people who get very severe COVID and die. And the other big discovery was that some people make antibodies against these very precious proteins. Again, another big puzzle. Why do some people make antibodies against these proteins and stop them from working properly? So it turns out it's more common in older people. As we get older, we're more likely to make these autoantibodies, and then it seems more common in men. So really cool stuff.
It was such an important discovery in our field, actually, when it came. You were on that paper, Cliona. Let's make that clear. Cliona was part of this, which was tremendous. Part of our COVID center. And it was a fantastic discussion. Imagine for a minute, just to tell you again, you've got these interferons, your body makes them, they fight viruses. And you begin to neutralize your own interferons. It seems outrageous. Like, why would that be? And we don't know why. I mean, it's a mystery. Again, it's something to do with the genetics of the person. You neutralize a very important part of your own immune system. Now, again, it could partly be, and Cliona mentioned this earlier, there's a role for interferons in autoimmunity as well anyway. In other words, if you have too many interferons, it'll turn on your immune system and you begin to attack your own body. Lupus is a great disease. You may have heard of lupus. Lupus patients make too much interferons for some unknown reason. So maybe it's trying to block autoimmunity in some strange way. It's kind of a consequence of a break being turned on that shouldn't be turned on because it's happening in infection. You don't want the break in infection, especially early on, because if the break is there, you'll get infected and you'll die, you know. So this is a very active area in immunology, is immunogenetics, and trying to understand that interplay with the genes and the immune system to explain some of these clinical features. And it always starts with the patient. Like why does John Smith die of COVID? It begins with that question. And then how many patients were involved? You had tens of thousands of patients in the end, didn't you?
Yes, because
across
there are
all the
different
world.
reasons. Yeah. Can we mention actually another thing that makes us susceptible? When you talk about nature via nurture, something that I think we don't talk about enough, but as soon as I say it, everybody will say yes, of course. Any lower and everybody, again, COVID really revealed this. Poorer people suffered worse.
Yep.
And they were more. And there are social reasons why this happened. They live in jobs or work in jobs where they're exposed an awful lot. They have to go out an awful lot. Poorer people live in environments where they're sharing spaces. But besides the actual social things, it turns out that poverty, the stress of poverty, compromises our immune systems.
Yeah.
And also that can be continuous. And that's another great collaboration that I'm part of, Luke, that the one in France in the milieu with Pasteur, with Dara Duffy, where they look at 1,000 healthy French people. Just recently, this paper is ready. It's not been reviewed yet. But
is there such a thing? These French aren't healthy. They're knocking back the wine to beat the band. They're eating pate.
Yeah, some of them are healthier than others, though. Of course,
yeah.
They were selected for their health.
Right.
But it turns out in the 1,000 that some are much more comfortable, well off than others.
Yeah.
And we were able to identify a lower socioeconomic group and then look at their responsiveness to viral ligands. And sure enough, these people who are now living are able to volunteer for a study, and so are leading reasonable lives. But nevertheless, the constant stress of their background poverty is compromising their immune activity.
It's hugely important. No, and of course, we often talk about inequality, don't we?
Yes.
Sadly, infectious diseases are massively unequal.
If
you're from a poor background, you have a higher risk of dying of any infection, actually. You've definitely got a higher risk of COVID, as we knew through the pandemic. And the big question is, again, that's a scientific question, that's an observation. And the question is, why is that?
Yes.
And as Cliona says, it's multifactorial. But one clear reason is stress, no doubt about it. If you can't feed your kids, you're stressed.
Exactly.
And it's cortisol. We know a lot about the immune system and stress, by the way. There's been big advances in the past 10, 15 years. That's the other hot area in immunology. It's called neuroimmunology. Yeah. And we know a lot about things like cortisol repressing the immune response. And that's chronic stress is really bad for your immune system. It suppresses NK cells. So we know a lot about the interface between stress and the immune system. And then, as we're discussing, can you do anything about it, as you've said? Like, what can we do? Obviously, increase their socioeconomic standing would be a huge benefit. But even in the absence of that, and the other thing is food. Very importantly, poor people,
exercise.
The lower socioeconomic, they eat processed food more. Their diet is worse than rich people because they can't afford to eat properly. And especially in America, where they live off processed food because they can't afford a decent diet. That damages the immune system. So it's like it's a perfect storm of things when it comes to low socioeconomic groupings. And then remember as well, as there's an epigenetic effect here, as we call this, which passes on to the next generation.
Exactly.
If you're from a difficult background, it'll go into your sperm and egg, and then the fetus that forms is carrying that burden that the parents had through no fault of their own, of course, because they were from a tough background. That transmits to the next generation. So in other words, they're already off to a difficult start. Even in the best scenario, they're already sort of in a difficult situation. So these things are extremely important. Try and sort that out. So poverty isn't just about the things we all know about. It's also about an immune system that doesn't work properly, which has all kinds of consequences.
Yeah. And so stress, and that's also then what's relevant to this audience as well, is about stress, because we all experience stress at different levels and learning how to handle it. I don't know if you know about this, Luke, but I did this I thought it was it was a fascinating study. It was with Kevin Malone, the most wonderful guy out in UC, the prof of psychiatry. Some of you might know him. But he was interested in this, neuroinflammation. And we did this study, which at the time I thought was totally mad. So at least 15 years ago, about 18 years ago, we looked at inflammatory cytokines in a group of his patients who were diagnosed with severe anxiety. And I said, this is ridiculous. There's no point in doing this. Lo and behold, yes, and we had a really nice control group. But the people with the chronic anxiety had higher levels of inflammatory cytokines going around in their circulation. Yep. And we published it just literally as an observational paper. But it is hugely quoted. Yep. Because it was one of the first that showed that. But one of our big, and I'm sure the audience will be thinking about this, where do those inflammatory cytokines come from?
Yeah.
And what part of the brain do they affect that make us feel? So, how does the stress generate the inflammatory?
We don't know. That's the thing that's missing. But this was a very I'm sure a very flaky field about 15, 20 years ago. It was very hard to do the studies. They weren't controlled properly. But it's got very respectable. The science has got much better. And the big one I like is the vagus nerve is a fascination, right? Yes. And the vagus nerve comes out of your brain, it splits into two, goes into your immune system, and it innervates your spleen, your lymph nodes, and then there's neurotransmitters being released that are controlling inflammatory cytokines. I'm very famous, a guy called Paul Peter Tack. I must give Paul Peter, he was a rheumatologist who was the first to link this to rheumatoid. Yes. And he showed if you stimulate the vagus nerve in your neck with a little zapper, it sounds unlikely, but it seems to be true. You zap the vagus nerve, it tells the immune system, behave yourself. And lo and behold, less rheumatoid. The symptoms in rheumatoid patients began to resolve a bit through a vagal nerve stimulation. So that's a really interesting development. And again, it seems, you want mechanism. As I said earlier, I'm only ever happy as clean and nose if I see a mechanism. The mechanism has to be the vagus nerve releasing acetylcholine in the spleen, and that dampens down the inflammatory process. And now you see a therapeutic effect in an inflammatory disease like rheumatoid arthritis. So one of my predictions, I'm sure you agree, one of our predictions is that will get better and better, that science.
Yes.
And the brain-immune interface will be more understandable.
Yeah.
And then there are ways to either use therapies or meditation, all these things. That again, that's got more respectable. That's definitely impacting on the immune system through these pathways,
Yes.
The famous cold water swimming, but they're all true. They're likely to be true, And now we're getting a mechanistic insight into them as well, which is tremendous.
And so to come back to the metabolites and exercise, if we talk about the metabolites that might be generated, because again, people think when thinking about energy and food, it's all to do with what we eat.
Yeah.
But our microbiome is as important an interface, again, between what we eat, our bodies, and the immune system.
It is,
Yeah.
There's two things going on here, I think, with the exercise metabolism connection.
Yes.
One is obesity is really bad for your immune system. It starts with that. The immune system sees fat tissue as alien and starts to attack it. And as Clean has just said, Lydia Lynch's fantastic work on this, the adipose tissue gets infiltrated with immune cells and it gets really irritated. And then that can then increase the risk of immune-mediated disease, you see. So anything that allows you to decrease obesity has a beneficial effect, because now you're losing that irritation from the body. So one reason exercise is beneficial is it controls fat metabolism and carbohydrate metabolism, and that means the immune system is now in the right environment. It's as simple as that, and that's really compelling. The second thing is your gut bacteria. They can be really problematic, and especially if your diet is rubbish and you aren't exercising, and that can be read out as an immune disturbance, because remember, the immune system is sensing the microbiome. It's designed to recognize bacteria in your gut. If that's disturbed, that irritates the immune system as well. So exercise has two effects. One is it balances your microbiome in your gut. And then secondly, it decreases obesity and decreases, metabolic disturbance in the broadest sense. And now the immune system is now not getting irritated by both those things and now begins to behave itself. And then you get a decrease in autoantibodies and a decrease in inflammation. So there's no question we're getting more insights into the mechanistic explanation of these.
Exactly. This is popping up. Megan wanted to mediate the questions, Luke, but that's popping up in the questions. Do you want to? Have you decided what order you want to do them in, Megan?
Yeah. Hi, everybody. I'm back. We've got a lot of questions coming in, and actually, you've sort of addressed some of them, but I'll just finish them off. Lisa, Cornelius, Ricardo, they're all really interested in diet. So they're saying, is there a way to boost the immune system through diet, dietary supplements, or lifestyle? And can you discuss if there are benefits in taking vitamins or other supplements? And Kalina, you mentioned it at the start, and I think a lot of people are interested, science behind fasting and how often we eat relates to immune systems. There's a few questions around that there. You can unpack those.
I'll have a go first. I mean, you got to be careful with these things because there isn't much evidence actually that food supplements make a difference. Isn't that strange? Yes. Now, there's some trials with certain things and they see a 5% effect and the label says it boosts your immune system. Whenever I see boosting your immune system, I'm immediately suspicious. Yes. You can't, the only way to boost an immune response is a vaccine. Yes. It's more about modulation. We hate the word boost. So it's a bit strange. Having said that, a balanced diet is the answer. It's the same old thing. If you have a normal balanced diet, your immune system will like it. There's no need.
Low fat and low sugar and low alcohol.
All those things, yeah.
All the things we love.
I think I saw recently, there was a great thing in The Guardian actually about this, and it said the best way to keep your immune system healthy is live like you're in the Stone Age. Now, what they meant by that was only eat food if it looks like food. If it doesn't look like food, don't eat it. Is the first thing. The second thing was de-stress and regular exercise, low impact exercise, like a Stone Age. In the Stone Age, we used to eat and then take exercise, and then the food wasn't processed. So those things are important. Now, if you're deficient in a vitamin, of course, then you take a supplement. And there's good evidence in various diseases of vitamin deficiencies. And the immune system needs vitamin D, it needs vitamin E, it needs the B groups. So in other words, that's a reason. If you're a healthy person, generally, you have a normal balanced diet, you don't need to take supplements, is the message here overall. That's the first thing, is an answer to that, I'd say. And then all these things that allegedly boost the immune system, I'm suspicious of most of those. I have to say, I'm never sure there's much evidence for them.
Can I tell them about our calf study, Luke?
Yeah.
We have a paper coming out. So I completely agree with Luke. There's so many studies out there claiming, for example, that vitamin D is going to cure everything, is going to protect. It is impossible to actually prove that. Now, having said that, we did a study on young calves where we supplemented them. And that's the only way you can do it, is in a controlled, as Luke said, is in a controlled in a study where everything is controlled, and we can't do that with humans. And they've got so all these calves are on exactly the same diet, but one half of them got vitamin D for 6 months, and then we looked at their immune responses afterwards. We had wanted to look at the adaptive immune response, and we do see a slight increase in their ability to be able to respond to viral ligands, but it was so slight, and they really got they were very, very carefully looked after, and it was a very clear study. Now, we've published that, but that's the only type of study that can really start going into mechanisms. Then is where it's totally controlled, because as we've said, your diet, your exercise, all the other things are going to affect. So I get really upset when I walk into pharmacies and I see people paying a fortune for these things, and then they give them to their children.
The message is simple. We've heard this for centuries. A normal balanced diet is fine. Now, there is an issue that some people, again, will have different genetics and might need supplements. and might need certain things. But it's a minority, is the way to think of it. The general public, normal balanced diet is fine. And then the odd bit of exercise, as we know, is very important for lots of different reasons. One is your metabolism is healthier if you take exercise. You're burning fats, you're burning carbohydrates. The body loves all that. The circulation, remember, is really good. There's some great studies showing if you increase circulation, the immune system loves that. It's surfing now on your blood, you see. And the lymphocytes love to surf in your bloodstream because the blood's moving faster, It's because obviously you increase blood flow with exercise, and then you de-stress. Again, very famously, exercise decreases stress. And now you're getting rid of the negative effect of stress on the immune system. And that's why we advocate for exercise. But we've known this, Jonathan Swift himself said your best friend is Dr. Diet, Dr. Sleep, and Dr. Exercise, and Dr. Mirth, he said. A bit of a laugh now and again is very important. So doctors have known this for centuries, haven't they, Clean, anyway? I guess all we're knowing now is the mechanism behind it is getting better understood.
Yeah, unfortunately, there's no silver bullet, but now we know why. We need
to.
Now we know why we need to do all these things. So that is always interesting.
We want to have our cake and eat it, us humans, don't we?
Exactly.
But look, we're not supposed to have cake. It's not great for
we're not on the cake.
Modification, absolutely. That's the whole thing about it's the amount. It's the amount. It's not the of course it's the what as well.
Right.
Can you speak to that for a minute, Cliona? You mentioned the fasting, and a few people have asked about that.
Yes.
The amount and the timing.
The amount of, yes. So it seems that this has got to do with both the actual metabolism. So Luke is better off describing what the switch is when we've stopped working. All I know, this is why it's not, is my own personal experience was that the only way I could shift the COVID stone, I happen to be in a very fortunate position where I was sharing a very nice house with my husband, who's a brilliant cook, and a son of ours who's a brilliant cook, and I like cooking. So there was an awful lot of cooking going on and special treats being, and on went the stone, and it was a disaster. And I found the only thing that worked was 2 days fasting. So I do 2 days for 500 calories per day, and then no alcohol for 4 days. Now, Luke, what is happening to my metabolism if I'm existing on 500 calories a day?
But you must have been hungry, were you? That's the first thing. The trouble is,
on the second day, what's really interesting is you stop noticing The
Oh
first
yeah, you
day
get
is
used to it.
difficult,
Yeah, yeah.
and the second day is much. Well, of course, the second day is much easier because you know you're back on to food again the next.
Yeah.
Yes.
It's very difficult. We know it's called a caloric restriction. If you decrease calories, it's very beneficial. Start with
Yes.
that. And they've done this in non-human primates. There was a great study done where they restricted calories in monkeys and they aged more slowly. Their skin was better, their eyes were better, their immune system worked better. So we know that if you can decrease calorie intake, it's beneficial. The trouble is us humans, we can't do it. We haven't got the willpower, because we get too hungry. And this is the difficulty,
Can we tell them about this? Can we tell? Sorry, I should have mentioned this. Can we tell them about the studies done on flies and mice? Well, I've told you about this actually. It was done on humans, but the flies and mice with rapamycin is an immunosuppressant that blocks mTOR, a pathway that's really fundamental to metabolism. And the mice and the Drosophila flies all lived longer. When this was, and it's an immunosuppressive.
Yeah.
It's used. Yeah, go on, will you?
What they showed there was if you decrease calorie intake in your body, certain biochemical pathways get triggered, right? And one thing is you burn fat stores because you need nutrients anyway. You've built in fat stores in your body, right? So less fat intake, the body needs energy, doesn't it? It starts to burn your own reserves. And that's a very good thing. You're burning fat now. And again, the obesity goes down. The immune system isn't being irritated. We know the pathways that get triggered. One is called mTOR. And lo and behold, then, if you target mTOR rapamycin and you mimic this, it's called pseudo-starvation, they call this, by the way, because you're mimicking the starvation state with a drug, is the way to think of it. In other words, you're enabling a pathway that's normally triggered by decreasing calories with a drug that happens to trigger mTOR, and that creates the same metabolic change then, right? The other one I like is a drug called metformin.
Exactly.
So metformin triggers a thing called AMP kinase, and that's exactly what gets turned on when you're starving. In other words, you're mimicking the starvation state with a drug, and maybe that'll be the answer, by the way. In other words, we haven't got the willpower, have we? To lay off the bag of crisps or whatever.
Yeah, for those of us who are accused of being hangry on occasion, that's maybe not going to work. But this is great. We're moving into a slightly different area because you both mentioned stress. Obviously, it's a huge thing during your discussion. And Melanie, I love her question here because she's brought it back to the title of the webinar. She says, if a clear stressor on your immune system is stress, how do you stop yourselves from getting stressed from the sheer amount of information and things that can negatively impact our immune systems and cause disease? How do you both keep
Well, I'll tell you, I'll go first. I hate to interrupt you. I'll tell you what it is. Social interaction is a massive de-stressor for most people.
Yes.
For most people.
Yes.
We've all got different personality types, haven't we? Me and Clean are very antisocial. No, but the fact is, we evolved, again, think about the Stone Age. What were our bodies doing then? We evolved to be social creatures. Really important. And that is a massive de-stressor, as long as you're mixing with someone who's trying to kill you, of course. But in your own community, it's a massive de-stressor. And all the right hormones are there and the balance in your brain. And there's massive studies on this, obviously. Social isolation is the biggest stressor almost that's out there. And we know that. And that increases risk of all these diseases as well. So the best way to de-stress, actually, go for a cup of coffee with your friend. Have a conversation. Go for a walk is even better because now you get exercise as well. So number one is try to be sociable. Difficult. It doesn't have to be a gang of people. It can be a close friend. It can be whatever it is. So that's the major way. And then, as we know as well, things like music, reading. We all know these de-stressors, don't we?
And laugh. Actually, look, there was a paper just about how laughing actually decreases the inflammatory response.
That's right. Well, there was a great study, which I mentioned in one of my books as well. They got women. And again, the sex difference is so important, as Cleena said. If you do a mixed sex, there's too much noise that there's men and women together in more ways than one.
Yeah.
If you just get a bunch of women, they got to watch a movie. It was when Harry met Sally. They measure their laughter. I'm not joking. They measure it. They put a strap around their bellies for what's called mirthful laughter. Real laughing as your belly moves, right? And they can correlate the number of laughs with NK cell activity in their body.
Come off it. I haven't seen that paper. If
you look at a paper, it's a reputable journal, right? And the more you laugh, your NK cells laugh as well. And the control movie was some kind of industrial movie that they didn't laugh in. It was a well-controlled study, And then we know laughter boosts the immune system. There's direct evidence for that. Now, whether it's true or not, I don't know. But still, there was one study suggesting that.
Yeah, but
that ties into actually two questions that have come up from Rachel and Noreko. Your mental state. Is there a correlation between mental illness and inflammatory conditions? Has there been any research on connections between anti-inflammatory treatments for mental illness or the antidepressants, anti-anxiety medication impact on inflammation?
it goes more the other way. I mean, the big
Yes.
breakthrough, in my opinion, in depression is it's driven by the immune system. And there's lots of evidence for this now. And they noticed this first in rheumatoid arthritis. Now, rheumatoid patients are inclined to have depression. It's a higher incidence among rheumatoid patients. And the theory was it's been caused by having sore joints and you get depressed. It wasn't. It was the cytokines being made in the joint were going to the brain and causing the depression. And when they blocked this thing called TNF, within a few hours, the depression began to lift. Isn't that incredible? And they still had sore joints because it took a bit longer for the joints to repair. And they all reported this, it's called an anti-TNF high, actually, because you're blocking a cycle. Now, of course, remember, this evolves during infection. When you're infected, you feel a bit depressed anyway. And that's designed to get you under the duvet, away from the tribe.
Into your cave, away from saber-toothed lion.
It's actually called sickness behavior, and it's driven by cytokines. If you're making cytokines in rheumatoid with no infection, you feel the same way as if you got the flu, And therefore, blocking these cytokines could be a new frontier for antidepressants. The new generation might well be drugs that target the immune system. Now, in terms of antidepressants, very interestingly, there's some evidence again, if you relieve depression, your immune system likes that as well, and now it begins behaving itself. So again, you might begin to see a limit in some of the inflammatory. There's less evidence for that, I must say, but still there's people interested in trying to examine whether antidepressants are beneficial for your immune system. And they probably will be, because you've got less stress and less other negative consequences of mental health then, and that would be read out as a more, as I say, an immune system that's more in order, as it were, and behaving itself.
Luke, we should mention, I see it in the questions there, and surely stress, a small amount of stress is a good thing.
Essential.
And I think, all the psychologists would all say that.
And that's been shown as well. A little bit of adrenaline actually stimulates the immune response.
Exactly.
And that makes sense, because if you're under attack, say you've been bitten by a tiger, right? You better get your immune system going there, because now your skin is broken, and adrenaline brings out the immune system. So acute stress is great. And that's why don't be frightened of a bit of stress. That's the message I give people always is, don't worry if occasionally you get a bit pissed off. It's the chronic stress that's the worry here. It's purely chronicity. And that's why the poverty thing and the people in those lower groupings, they have chronic stress all the time.
Or if you don't have strategies for doing it. I'm always saying, because
strategies to handle it. Yeah, exactly. Yeah.
It's terrible to see the students. It's really sad. I don't know if you've noticed it in the undergrads this year, Luke, but the final years, because they're the ones that have had 2 years of COVID. They've been locked up. They've really lost on the switch.
It's very tough on them.
Their levels of stress and anxiety is.
We're giving them all 2-1s, Fiona. Is that the reason?
No, I'm bringing them.
That's a joke.
No, I'm bringing them to coffee, and I slag them, and I tell them, and I get them to present. I really give them stress. I tell them they have to present, and they've got tough projects, but really cool projects. So they're beginning to emerge out of it.
But they are. I've noticed that myself. It is getting better.
Yeah.
Well, we're coming up. We're coming up towards the end, and we've time for one last question. And we'll try and keep our response pretty tight. But given it's flu season, and vaccines between flu and COVID are on everyone's mind, Nicola, who is an ex-geneticist and now in GP in North Wales, is currently trying to persuade patients on a daily basis to have the flu vaccine. And they're happy to say, I got mine. What key piece of information would you like patients to know to help them make their decision whether or not to get it?
I'll take that again, Megan, because I can say it in one sentence. It might protect against Alzheimer's. It'll certainly protect.
Really?
Yeah, that's very interesting, that development. Yeah.
And infection is really, flu infection is bad. It does kill people, and it particularly can be bad so why anyone would not take the flu vaccine? But there's no point in getting agitated. Just present for me to get agitated. Or now I know the GP won't.
The bottom line is very simple. I'm sure Nicola knows this. These are nasty diseases. The vaccines will protect you. It's your choice if you want to take them or not. Secondly, you might help your community by taking them, because you're still in the workplace, helping doing your job, not getting sick, and you aren't spreading it. There's some evidence, as we know, they block transmission, and you won't infect other people. So there's some reasons. And appeal to people's better natures. That's the best way to approach it. And then you won't get Alzheimer's as well. How about that?
Exactly.
I'm feeling very virtuous now that I've got mine. Fantastic. I'd like to say thank you both so much for joining us today. It's been a fascinating and very wide-ranging conversation. Thoroughly enjoyed it. I hope our audience did as well. You've been incredibly generous with your time and expertise, so thanks so much. I also just want to thank a few of my colleagues over in the Trinity Alumni Office who have helped organize this and are playing an absolute blinder in the background with the technical stuff. And of course, all of you in the audience, thank you so much for joining us. It's been an absolute pleasure to interact with you today. It's one of the joys of these webinars is the ability of people to send in questions. Unfortunately, there were so many questions and we weren't able to get to them all, but we appreciate you sending them in, and hopefully a few of them did get addressed there. And we will hope that you will join us for our next webinar. There's details here up on the screen now. So next month, we'll be welcoming businessman and multiple All-Ireland winner, both as a player and a manager, Pat Gilroy. And he'll be joining us with the Sideline CEO, Lessons in Believing and Achieving in Life, Sport and Business. Pat will be talking to Neil O'Driscoll of Trinity Sport about the highs and lows of his time with Dublin Gaelic football, his years at Trinity with teammates like Joe Brawley, and why community and relationships are essential to any success, whether it's in business or in sport. So details on how to register for the next webinar will be sent via email and posted through our various social media channels in the coming weeks. If you have any questions or comments regarding this webinar or the series itself, or any questions at all about the activities of the Alumni Office, you can contact us at alumni@tcd.ie. So now I'll just say thanks again for joining us. Have a great rest of the afternoon, and we'll look forward to seeing you next month.